Welcome to the lesson overview for 2.07, Part 1. This lesson is a bit longer than 15 minutes, so there are two parts. In this lesson, I will explain how to derive the formula for the volume of a pyramid. We will solve real-world problems involving the volume of a pyramid, determine the volume of a pyramid, and name the parts of a pyramid. This is a pyramid. A pyramid is a polyhedron with polygon base and lateral faces. The faces are triangles that meet at a common vertex. The common vertex is the vertex of a pyramid. Pyramids are classified by the shape of their bases. For example, if the base of the pyramid is a square, the pyramid is called a square pyramid. A regular pyramid has a base that is a regular polygon and lateral faces that are congruent isosceles triangles. The edges that form from the base of a pyramid are called base edges. The remaining edges are called lateral edges. The altitude of a pyramid is a perpendicular line segment that joins the vertex to the plane of the base. An altitude might lie inside, on, or even outside of a pyramid. The height of a pyramid is the length of the altitude. The slant, however, is the length of the altitude on the lateral face. A right pyramid's altitude intersects the center of its base. An oblique pyramid altitude does not. Cavalier's principle says that if two solids have equal heights and the cross sections formed by every plane parallel to the base of both sides have equal areas, then the two solids have equal volume. Now let's see how the Cavalieri's principle to determine the formula for volume of a pyramid works. To understand the formula for the volume of a pyramid, start by looking at three square pyramids shown here. Each of these pyramids is oblique with one lateral edge perpendicular to the base. These perpendicular lateral edges are the altitudes of the pyramids. The base edges of each pyramid are S units long, making their base areas S squared. In other words, S can be used for the side length. Because all three of these pyramids have the same base area, their cross-sectional areas are also equal. Furthermore, their equal cross-sectional areas and equal heights mean that by Cavalieri's principles, their volumes are equal. What would happen if you joined these three pyramids at their vertices? When the three pyramids join together at their vertices, a cube is formed. All three pyramids have the same volume. So the volume of one pyramid is 1/3 the volume of a cube. So what you can conclude now that you know the volume of a cube or any other prism is by multiplying the area of the base by the height, or capital B times h. According to Cavalieri's principle, you can apply this formula to the volume of any pyramid, including oblique pyramids. The formula for the volume of a pyramid is V is equal to 1/3 times the base times the height. Let's identify the vertex, the base edges, the lateral edges, the slant height, and the altitude of this pyramid. Notice here that the vertex is A. The vertex is the point where the lateral faces intersect. The base edges are the edges that form the base of the pyramid. The base edges are B, C, C, D, D, E, and EB. The lateral edges are the edges formed by the intersection of two lateral faces of the pyramid. Notice here, AB, AC, AD, and AE are the lateral edges. The slant height is the height of the altitude of the lateral face, kind of like if I was climbing up this pyramid. The slant height is different than the altitude or the height of a pyramid. The altitude or the height of the pyramid is from the base center up to the vertex. So in this case, AF is the perpendicular altitude of the pyramid. Which of the segments represent the slant height of one of the lateral faces of a pyramid? And which one represents the altitude of the pyramid? Pause the video and see if you can guess. If you guessed that the slant height is AB, you guessed correct. Notice that the slant height is on the lateral face from the middle of the base straight up, creating a perpendicular line. The altitude, however, is also a perpendicular line, but it joins the vertex of the plane of the base. Notice that one endpoint of AC meets at the vertex A, and the other endpoint meets at the vertex C. This base happens, or this altitude happens to be outside of the pyramid. Let's determine the volume of a square pyramid. Here we can determine that the base is area equal to S squared. And we notice that S is 10 centimeters. 10 squared is 100. Therefore, the area of the base of this pyramid is 100 centimeters. The altitude is the perpendicular line that joins the vertex of the plane to the base. So it's going from Y to T or T to Y. This is 12 centimeters. Here we're going to say 100 times 12 divided by 3, or a third of 12, or 12 times 1/3, which equals 4. 100 times 4 is 400. Therefore, the volume of this pyramid is 400 centimeters cubed. Determine the volume of the triangular pyramid. We're going to start with the base again. Notice that the base is 8 meters. In the triangular pyramid, we're going to use the formula area equals half of the base times the height. So we have this triangle right here, and we're going to find the area by saying 8 times 10 divided by 2. Therefore, our base is 40. 8 times 10 is 80. Half of that is 40, or half of 8 is 4 times 10 is 40. Finally, we're going to determine the height of the pyramid, which is 15 meters, and we're going to multiply the base times the height by 1/3. 1/3 of the base times the height. So 15 divided by 3 is 5. 40 times 5 is 200. Let's practice determining the surface area of a pyramid. The surface area, known as capital S of a pyramid, is the sum of the areas of the outer surface of the pyramid. We worked on this when we worked on composite figures. The base area B of the pyramid is the area of its base, and the lateral area is the area of its lateral surface. Therefore, the surface area of a pyramid is the sum of the lateral plus the base, which equals S. So the sum, adding L and B together to equal the surface area. The surface area of a regular pyramid is S equals L plus B. S is the side of the base, and L is the slant height of the pyramid. Here we can open this up to a net and find that we have 4 sides and 4 lateral slants. Look at the net. The lateral faces are 4 congruent isosceles triangles. The lengths of the base of each triangle is S units, which is the length of one side of the pyramid's base. The height of each unit, L, is the slant height of the pyramid. Now we can form the formula half times S times L. 4 of those is going to give us 4 times half times S times L. This is going to give us our lateral formula. Here we have the lateral is equal to half L times P, or the perimeter, 4 of the sides. So our full formula for surface area is half of the slant, or the lateral edge, times the perimeter times the area of the base. The surface area of a regular pyramid with a slant height L, perimeter of its base P, and area of its base B is half the product of the slant height and perimeter when the product is added to the area of the base. Let's go ahead and determine the surface area of the square pyramid. Notice here, we're going to square the side. 10 squared is 100. The perimeter is 4 sides, which is then 4 times 10, giving us the perimeter of 40. And then the slant height, which is L, is 14 yards. Now we can take all of the information that we have gathered and plug it into our formula. Half times the slant height, 14, times the perimeter, 40, plus the base, 100. This is going to give us half of 14, which is 7, times 40 plus 100, which is 380. If you have any questions on this part of the pyramid volume, please feel free to reach out via email or text.